Alright, welcome back guys. This is Unit 1 for STAT-2510 and this is going to be our second video for it. Now if you've already watched the first video, you kind of know what I'm doing here, but if you haven't, this is basically just a homework review, sort of introducing all these topics to you. Now you've got to remember this is not a substitute for going to class. You should still do that. This is just complementary on top of it. Alright, so the first thing we're going to start off with is a couple definitions. And the first one's going to be variable correlation. This describes how closely the two variables move together. So if one variable moves one way, the other one would move very similar to that one if they were correlated. The explanatory variable is what you manipulate or observe changes in. And the response variable is what changes as a result of the explanatory variable. Another way that you can put it is the explanatory variable is the x and the response variable is the y. And here's a picture of a linear relationship. It's just a straight line. And then a nonlinear relationship would look something like this, more of a curved line in the data. So a unimodal distribution of data looks like this, to where there's one mode in the middle, one big peak there. Bimodal would look like this, where there is two peaks, or so there's two peaks in bimodal. And then uniform is straight across the whole time because the data is uniform, so it's evenly distributed no matter what value you look at. And our next one would be the mean, and that's our average, and it's also called expected value, and it's used as a measure of center with unskewed data. And then we have our median, which is the observation in the direct middle of the outcomes, and that's how we measure the center in skewed data. So if we come back up, or if we go down here and look at skewed data, so this would be skewed to the left or skewed to the right, and we would use median to measure the center of that, and then we would use mean to measure the center of this symmetric data. So the next thing we have would be standard deviation, and this is how spread out the data is relative to the mean, and this would be our measure of spread in unskewed data. And now we have our interquartile range, and so the interquartile range is going to be used in skewed data to measure the spread. And so we have our 75th percentile, which is right here, so 75th, and then this would be our 25th percentile, this line. And so the IQR would be the 25th percentile minus the 75th percentile minus the 25th percentile. And it would be the numbers that are there for the actual data. And then I've already showed you the skewed left, skewed right, and symmetric. Then it's just skewed whichever way the data trails off in. So right, left, symmetric. All right, so now we will move on to working some problems. And as you can see, this this video will be variable correlation, variable association, measures of center and spread, and then we'll throw some RStudio in there at the end to teach you some basic functions for RStudio. So for this first one, we want to look and see how these are correlated. So this first one, if you draw a best fit line, would look something like this, right? And it would be positive association and linear. And so this next one, number 2, it doesn't look like they're super associated, right? Because there's dots up at the top here, 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 and then there's still some at the bottom over on all sides. So this one would probably look like that. And that's no correlation there. This next one, if you'll remember the graph that I showed you earlier, is a curved line here. And so that means that they do not show linear correlation, so this would be nonlinear. And then this last one would be down, sort of like that, so negative correlation, but this one's also linear. So we have linear and positive, and then this one is no correlation. And this one is non-linear. And then this one is negative and linear. Okay, so now we are on to the first real question that we have, and that would be looking at this graph and say, what is the explanatory variable? And so, like we said earlier, the explanatory variable is x, and the response variable is y. So what are those going to be in this problem is the question. So the x value, if you'll remember, is always on this bottom axis. So our x here would be percent with bachelor's degree. Okay, and response variable, I mean, there's only one left, so it has to be the one on the y. So response variable is going to be per capita income. And so if you think about this in the context of the problem, is the explanatory variable is like what you would be changing. So you would change what you're looking at, you would change the percent with the bachelor's degree, and then what you're looking for with that is their per capita income. So as we observe different people with percent and bachelor degree, then we're observing their per capita income from those people. So if we look at it here, this graph obviously trends towards that line right there. And this would be a, if we look back up here, which one of these does it most look like? And I would say it looks most like this one. So that means we're going to have a positive linear relationship. And the fourth part asks us, is correlation an appropriate measure of the relationship between these two variables? And yes, it is, because it's a strong relationship. So yes, because it's strong. And when I say strong for the relationship, is that you can see on this line that the data points don't really differ from that line. This trend line is very accurate to how the data looks. As you can see, as you go further to the right, the dots go further up. So this is a strong relationship. All right, next question. This one asks about dietary concern score, which it doesn't really matter what it's asking about. It's more asking us what we're supposed to do with this. So we're going to look at this and then we're going to identify what the distribution looks like. So if you remember on the definitions page, I showed you a unimodal, bimodal, and uniform graphs. And so which one does this most look like? I would say unimodal. We have one mode right there and it's at the top, and then the graph sort of just goes down from there. So I'm going to say unimodal. And if we look at this, right, we have two different measures of center and spread, and one of them is used for skewed data and one of them is used for symmetric data. And so this is obviously skewed, as we see there, because it tapers off to the right. So that means that we would have to use median and IQR in order to measure the center and spread of this data because it's skewed. So how do the median and mean compare? So in a skew like this graph, the mean is going to be closer to the center, so the mean might be around here, and then the median might be over here, because the data is so skewed that there's more observations to the left, which is going to keep the median over here, but then the observations to the right affect the mean more, so the mean would be moved further to the right. So the mean is greater than the median. Is greater than the median. All right, that question's pretty easy. Okay, so this next one asks us to match each of these graphs to our box plots down here. So we would have regular plots up here of bar graphs of our data here. So these are bar graphs. And then these are box plots. So if you recognize the box plot, it's because that's what we used earlier in our definition of IQR. And so this was our box plot here, and we have our bottom, and then our top, and then the IQR here, which is this little box. And then also we have our mean right here in the middle. So that is this. No, I'm sorry. Actually, that is the median because that is 50% of the data. So I apologize. This would be median. So that means 50% of the data is to the left and 50% of the data is to the right. So that's what a box plot shows us. So now we're going to come down here and we're going to say, all right, which of these looks the most like this first one up here? So we're going to be looking at A in the top. And I would say this is not uniform, but it's unimodal, and it looks symmetric to me. So we have one mode, and it's in the middle right here, and it tapers off to the right, and it tapers off to the left. So this would be unimodal and symmetric to me. So which of these box plots looks most similar to that? So it's not going to be this first one because of all these outliers up to the top, which would be to the right in our data up at the top. So it's going to have to be this second one right here because we still have a few outliers on each side, which would be these and these, but we have a fairly symmetric distribution here, or fairly symmetric distribution here in the middle. We have about the same here as we do here, and this median is pretty much in the middle of our box. So this means that if we come back up to the top here and we say C, obviously we can tell that C is connected to this one because of these outliers here and these outliers here. That's what we're looking at there, is those two sets of outliers match each other, which obviously only leaves us these two to connect at the end. All right, so next question is another question about box plots. So this shouldn't be too hard because we just looked at box plots up here in the last question. So our IQR is the box in the middle, would be the top of the observations minus the bottom of the observations. And so based on IQR, which feed type has the greatest consistency distribution? Which has the least spread is basically what it's asking. So if we come up here and look at it, we would have, this would be the spread of the first one, this would be the spread of the second one, this would be the spread of the third one, fourth one, fifth one, and the last one. So right immediately I would see it's between this one, horse bean, and sunflower, because obviously those boxes are a lot tighter than the other four. And if we look at it, it appears that sunflower would win this one because it is just a little bit smaller of a box than horse bean. So I'm going to go sunflower there. So number 2, which feed type has approximately 75% of its data above 275? So where would 275 be on this graph? Right around here. And let's just draw a line across that. And if you see where I just drew that line at, would be right at the bottom of Kaysen. And it would be right at the bottom of the box of Kaysen. So right here, this line is the bottom of the box, and that means that it's the lower 25% of the data is below it. So this right here is 25%. So that has to mean that the rest of the data above it, which is all here, would be 75%. And if we look, that fits right on our 275. And so I would say it's pretty obviously that one. So okay, so for that. All right, next question. So this is giving us a frequency table. Not a frequency table, I'm sorry. This is just another distribution graph. So this is just another bar graph, and it's basically telling us how much between these two observations here is the percent of the number of samples. So if we see 0 to 1, this would be about 26%. So 26% of the samples contain soil organic matter, which is our explanatory variable, or our x variable, 26% of the samples contain soil organic matter from 0 to 1%, is basically what all it's saying. So the first question is asking us what percentage of samples have more than 2% soil organic matter. So we know that 2% would be right here, if I drew that line. And so this would be all the samples this way. So it would be 2 through infinity. And that means we would add up this number right here, however much that is, and then however much that is, plus this one, plus this one, plus this one. So I would just go ahead and estimate that around, let's see, if we say right here would be, I don't know, that looks like 17% to me. This one looks like 9%. This one looks like 8. This one looks like 3 and 3. So let's add those up. 17 plus 9, 26 plus 8, 34 plus 3 plus 3 would be 40. So I would just go ahead and guess 40% here. And that would be more than 2% organic soil matter. And the next question would be what percentage of samples have between 1 and 4%. And so I'm not going to do this math because it's going to take a little bit. But anyways, it would be from this line right here to this one right here, right? Because that would keep us in between 1 and 4. So the 1 and 4 would be right here. So basically you would add up this 17 that we had here plus this 9 plus this number right here, which would be about 34. So 17 plus 9 was 26 plus 34 gives us about 60. So I lied. I said I wasn't going to do it, but then I did. Sorry about that. Okay, so this next question is asking us basically what is the shape of these distributions. So if we look at this first one right here, I'm just going to go ahead and draw a little graph over to the side, and we'll try to estimate what it would look like. So our mean is at 9.5, so 9.566, and then our median is at 9.566, and then our mean is just barely more than that. Our first quartile would be over here, third quartile would be over here, and that looks about symmetric to me. So I'm going to go ahead and say this one is symmetrical because the mean and the median are so close to each other, and the third quartile and first quartile are fairly evenly spread away from the mean and the median. So right, if we have an even spread to the right and an even spread to the left, then that's going to signify our symmetrical data. All right, so for number 2, we have our mean and our median are different on this one. So I'm going to draw us another graph. And so our mean is over here, and then our median would be at like 9, and our mean is at 6.6. And so if our third quartile is pretty close to the median over here at 10.075, and then our first quartile is way down here to 1, that means that our graph looks more like something like this, right? Skewed off to the side, because if you remember up here on this problem, when we were skewed to the right, that meant our mean was closer to the middle than our median over here. And when our median was to the left, it was skewed to the right, and since this one, our median is to the right, then that means we are skewed over here to the left, so skewed left. All right, and the last one, we have the first quartile around 9.42, median 9.5, mean 9.6, 9.68 for the third quartile, and this sounds like it is uniform to me because we have to stay kind of constant over that whole data set. Just because those numbers are so close to each other, they have to be all together. So this is going to be uniform. All right. So that's going to conclude our notes part, and the next part of this video will be our studio help. So, next thing we have our studio. Your teacher should have already introduced you to this website, and you should know the basics of how to get around on it and how to type things into the console right here. So I'm going to teach you how to define a variable, and then I'm going to teach you some commands to show about the data that we enter. So the first thing we're going to do is we have a data set over here, and I'm just going to copy it. We're going to run back over into RStudio, and I'm going to call it an uppercase X. And so when you want to define a set of numbers, you start with a less than sign, a dash, and then a C, and then open your parentheses, and then I'm just going to paste it in there, click enter, and if you look over here into our environment, we now have X, and it is set to those 7 values. So if we want to know about X, we would say summary of big X, and then it tells us our minimum value, our maximum value, our mean, our median, and then our first quartile, third quartile. And there's a couple other things we can do. We can say the standard deviation would be SD of X, and the variance would be VAR of X. Alright, so that's to learn about the statistics of that variable. And now we can say plot of X, and then you'll see over here that we have a dot plot come up. And then we can say box plot, which is what we've already looked at in this video. So you should recognize this would be our first quartile, third quartile, our median, our maximum value, and our minimum value. You should recognize that. That's a nice little plot right there. And then you can say bar plot of X, and it'll give you that. And so now let's do this with one more variable, or with one more set of data. So let's call this one Y, and then it was less than sign, dash, C, open parentheses, and then we will come over and do this data. So we'll paste it in there, and now we have Y defined as that. So now let's do a summary of our Y, and there we go. And let's do the standard deviation, the variance, and let's do a box plot of Y. Alright, there we go. It's as simple as that. Those are your basic RStudio commands for this first unit. Thanks for watching, guys. I will see you in the next one.